Welcome. So for this deep dive, we're really getting into some pretty fundamental questions about reality, wouldn't you say?
Absolutely. The source material we're looking at is from the first module of this course on analytic idealism.
Right, and it pulls from neuroscience, philosophy, evolutionary theory, all to kind of poke holes in our everyday assumptions about the world we see.
Exactly. The mission here, if you like, is to understand why our common sense view might be flawed based on what science and philosophy are suggesting now.
And just briefly, later modules get into physicalism, pancychism, analytic idealism itself.
Yes, empirical evidence, consciousness versus metaconsciousness. Quite a lot down the road.
But today, we're zeroing in just on this first part, the idea that our ordinary view of reality might actually be, well, incoherent.
That's the focus, setting the stage, really.
Okay, so the lecture kicks off with a scenario. Imagine you're on a plane looking out the window. Clouds, maybe some lightning. What's our immediate feeling about what we're seeing?
The immediate intuition, the sort of default assumption, is that what you see is the world out there. The clouds are the clouds, the lightning is the lightning as they exist independently.
Like our eyes are just clear windows.
Precisely. A transparent window onto reality. We just assume the world is the shapes, the colors, the textures we perceive. Our senses just reveal it.
Okay, that definitely feels like the common sense view. But the course immediately asks, is that actually true, given what we know now?
And the answer it gives is pretty blunt. No.
Right. Okay, so let's unpack the arguments for why not. The first one involves entropy. The second law of thermodynamics. Can you maybe give us a quick refresher on that?
Sure. Basically, the second law says that in a closed system, things tend naturally towards disorder, towards chaos. Entropy increases.
Like coffee and milk mixing on their own, but they don't unmix on their own.
Exactly that. That's a classic example. Order requires energy to maintain. Disorder happens spontaneously.
So how does this tendency towards disorder, how does that relate to us, to living beings?
Well, think about us. We are highly ordered systems, aren't we? Our bodies, our organs, they maintain incredibly complex structure.
Right, they don't just dissolve into a puddle.
Hopefully not.
Yeah.
And that maintenance, that fight against disorder, requires a constant input of energy. Metabolism.
Okay, so where's the connection to perception? How does entropy argue against the transparent window idea?
This is where it gets interesting. Consider the sheer variety and the disorder of states in the external world.
Right.
It's constantly fluctuating, incredibly complex.
Mm.
Now, if our internal perceptual states were truly just direct, one-to-one mirrors of all those external states.
We'd have all that external complexity inside us.
Exactly. Our internal state would become just as dispersed and disordered as the external world it was mirroring. We'd essentially, as the lecture puts it, dissolve into an entropic soup.
Wow. Okay, so maintaining our own internal order means we can't be perfectly mirroring the external world's disorderliness.
Precisely. Our perceptions can't be these perfect literal reflections. They have to be something else.
What then? What's the alternative view presented?
The alternative is that our perceptual states are encoded and inferential. They're not mirrors. They're more like the brain's best guesses.
Guesses based on what?
Based on the limited sensory data it receives. It's constructing a representation, an inference about what's likely out there, rather than passively recording it. Think of it as an encoded interpretation, not a literal picture.
The lecture used an analogy with numbered states, didn't it, to illustrate this compression?
Yes, that's helpful. Imagine the outside world has, say, 1,000,000 possible states, numbered 1 to 1,000,000.
Okay.
If your brain had to have a unique internal state for each of those 1,000,000 external states, that internal complexity would be overwhelming, thermodynamically costly, maybe impossible to manage.
Right back to the entropic soup problem.
Exactly. So instead, the brain maybe uses a much smaller set of internal states, let's say 1 to 100, to represent those 1,000,000 external states. It encodes the information.
So state #5 in my brain might correspond to a whole range of similar states out there in the world.
Sort of, yes. It's a compressed representation, an efficient summary that's useful for navigating the world without mirroring its full, messy complexity. Carl Friston's work gets into the mathematics of this, how the brain minimizes prediction error.
Okay, that makes the thermodynamic argument clear. Direct perception is just too costly, too disordering for a living system.
That's the essence of it, yes.
Now, there's a second completely independent line of argument coming from evolutionary theory.
Yes, and it's fascinating because it arrives at a very similar conclusion from a totally different direction.
So what's the evolutionary question here?
The question is, Would natural selection actually favor organisms that perceive the world truthfully, as it really is?
My first instinct is, yeah, surely seeing things accurately helps you survive.
That's the intuitive thought. But the answer from evolutionary game theory simulations and even mathematical proofs now seems to be
No.
no.
Evolution doesn't favor seeing the truth. Why not?
Because evolution selects for fitness what helps you survive and reproduce, not for accuracy and perception per se. Sometimes seeing the unvarnished truth might actually be detrimental to survival.
How so?
Think about Professor Donald Hoffman's analogy, the computer desktop.
Okay, the icons, folders.
Right. Are those icons an accurate representation of what's really going on inside the computer? The voltages, the magnetic fields, the silicon logic gates?
No, not at all. They're just symbols, really, a user interface.
Exactly. They're a useful interface. They hide the underlying complexity and give you simple, actionable symbols so you can write your document or delete a file efficiently. Trying to work directly with the raw code or the electronics would be incredibly cumbersome, maybe impossible for most tasks.
Okay, I see the analogy.
So the argument is that evolution has similarly shaped our perceptions to be like that desktop interface. It gives us useful symbols, what we perceive as objects, colors, sounds, that help us navigate the world effectively for survival and reproduction.
But these symbols, they don't necessarily resemble the underlying reality itself.
That's the claim. They hide the potentially overwhelming complexity of whatever reality actually is, and just give us the fitness-relevant information in an easy-to-use format. Seeing the truth might be like trying to interact with the raw code, too much information, too slow, not helpful for catching prey or avoiding predators.
So evolution might actually drive creatures that perceive truthfully towards extinction.
That's the startling implication. Fitness trumps truth, evolutionarily speaking.
Wow. Okay, so we have two independent arguments, one from thermodynamics, one from evolution, both suggesting our perception isn't a direct window onto reality.
Yes, the convergence is quite striking. Both suggest that what we experience, the clouds, the lightning, this room isn't the world as it is in itself.
It's more like a user interface, or a virtual reality tailored for survival.
That's a good way to put it. An interface designed to keep us alive and functioning, allowing us to maintain our structural integrity against entropy.
This leads nicely into another metaphor used in the course, the pilot in a storm. Can you walk us through that one? It helps distinguish accuracy from truthfulness, right?
Right. Imagine a pilot flying at night in a terrible storm. They can't see anything useful at the windshield. It's all darkness and rain.
Okay, so how do they fly the plane?
They rely entirely on their instruments, the dashboard, airspeed indicator, altimeter, artificial horizon, navigation system.
The dials and displays.
Exactly. Now, those instruments need to be accurate, right?
Yeah.
They need to provide correct information about the outside world, the plane's speed relative to the air, its altitude, its orientation. The pilot's life depends on that accuracy.
Absolutely. If the altimeter is wrong, big trouble.
Big trouble. But here's the key point.
Yeah.
Do those instruments look like the thing they were representing? Does the airspeed dial look like wind? Does the altimeter look like height above the ground?
No, of course not. They're just dials, numbers, pointers.
Precisely. They are accurate representations of reality, but they are not truthful representations in the sense of resembling reality. They provide accurate information about the world, but the representation itself looks nothing like the world.
Okay, I see the distinction. Accuracy versus resemblance.
And the analogy is that our perception is like that dashboard. The things we perceive, objects, colors, sounds, smells, tastes, these are like the dials on our dashboard.
So the solidity of this table, the color red, the sound of your voice, these are my instrument readings.
According to this view, yes. They provide us with accurate information that guides our behavior successfully. Don't walk into the table, stop at the red light, but they don't resemble the underlying reality that causes those perceptions.
So the world as it is in itself looks nothing like tables and chairs and colors.
It's a totally different paradigm, as the source puts it. It likely bears no resemblance whatsoever to our perceptual experience.
That's a pretty radical thought. What does this imply for fundamental concepts like space and time? Are they part of the dashboard too?
That's the logical extension, yes. If our entire perceptual experience is the dashboard, and we experience things within a framework of space and time.
Then space and time themselves are features of the dashboard, not necessarily features of the world outside the dashboard.
Exactly. There's no compelling reason within this framework to assume that space and time are objective features of the external world independent of the observer. They are the coordinate system of our interface, so to speak.
And are there other lines of evidence that suggest space and time might not be fundamental in the way we assume?
Well, yes, the lecture points to converging evidence. Think about general relativity. Space-time isn't a fixed background, it's malleable, affected by mass and energy.
Right, it warps and stretches.
And neuroscience shows how subjective our experience of time is. Even the perceived order of events isn't always fixed.
And physics is struggling to reconcile general relativity with quantum mechanics.
And many attempts to do that involve theories where space-time itself is emergent, arising from something more fundamental that isn't spatial or temporal. So the idea that space-time is part of our perceptual construction isn't completely out of left field, scientifically.
Okay, but what about scientific instruments? Microscopes, telescopes. Don't they let us see beyond our basic senses, get closer to the real thing? Doesn't that let us peek behind the dashboard?
That's a really important question. And the argument presented is that, no, they don't let us escape the dashboard paradigm.
Why not? A telescope shows us galaxies far beyond what our eyes can see.
It does, but how do you get the information from the telescope? You either look through an eyepiece using your eyes, your perceptual system, or the telescope feeds data to a computer, which generates an image or graph.
Which you then look at on a screen.
Exactly. Or think about a particle accelerator like the LHC at CERN. They don't see particles directly. They see tracks in a detector, or histograms on a computer monitor.
So the output of any instrument, no matter how sophisticated, ultimately has to be translated back into something we can perceive through our senses, back onto the dashboard.
That's the crucial point. Instrumentation extends the range and precision of our dashboard. It gives us more dials, more detailed readings, but it doesn't give us access to the world outside the dashboard framework. We're still interpreting instrument readings via our evolved perceptual interface.
So we can enhance the dashboard, make it more detailed, but we can't actually step outside of it to see reality directly.
According to this line of reasoning, no. We're always interacting with the world via this evolved interface.
Okay, let's try to summarize this first deep dive then. Our basic, everyday feeling that we see the world as it truly is, that's likely mistaken.
Yes, the arguments from thermodynamics, the cost of direct mirroring, and from evolution fitness trumping truth both strongly suggest this.
Instead, what we experience is more like an encoded interface, a kind of dashboard.
A dashboard that provides accurate information for survival, but whose representations, colors, sounds, objects, even space and time, likely bear no resemblance to the underlying reality itself.
The world we perceive is the interface, not the reality behind the interface.
Precisely. The phenomenal world is our evolved way of interacting with whatever is actually out there.
Which, of course, leaves us with a massive question, doesn't it? If this reality we perceive isn't the fundamental truth, then what is? What could that underlying reality possibly be like?
Yeah, indeed. And what does it mean for us, for science, for philosophy? We start thinking of our perception not as a window, but as this highly evolved, functional, but ultimately non-representational interface.
It certainly changes how you might think about, well, everything around you, something for our listeners to ponder.
It definitely reframes the entire discussion about the nature of reality, setting the stage for exploring what might lie beyond the dashboard.